So hello, good day. I'm Samuel Gonzalez, and I'm gonna be presenting how to configure SAVEC into views specifically in the KaoPing catchment area. So for starters, we need to set up the parameters, and to do so, we have to import SAVEC layers into views. Both files that were provided, KaoPing SAVEC RRCF export and import, need to be pasted into the ID map files area. After that, we proceed to set up the spatial data for this for SAVEC, and in that sense, we need to import the water level shapefiles into the map layers file. Three shapefiles complement the other three SAVEC shapefiles that we previously have pasted into the file in order to be able to display the spatial data. And after that, what we need to do is to set the water level shapefiles locations in views. Because we now imported it, we need to tell views where to find those files, and to do so we open the location sets 4.0 in the region config files, and we first set up the SAVEC shapefiles, the location, and we also put the location set ID for water level in the KaoPing area, plus the name of the shapefile that contains the data, and then RainGog stations, or the rainfall stations that are within the QPSums and the files provided. After that, we set the grid configuration in views to be able to display these stations, and to do so we check the QPSums files in order to extract the data for the KaoPing. So we indicate the number of the cells and the rows and columns, plus the X and Y values. After that, we create a model instance for SAVEC within views, and to do so, what we need to do is to import the SAVEC RCF KaoPing pasted into the module config files. After that, we proceed to declare the SAVEC model instance within views, and to do so, we go to region configure files and then to model instance descriptor 2.0, and then we create a new model instance description with the name of the file we just created, which is the SAVEC RRCF KaoPing. After that, we proceed to set the workflow, and to do so we create first the SAVEC workflow file within views, and to do so we just grab from one of the previous work files we have in the file, and then rename it as the SAVEC RRCF KaoPing. Then we open it and change the module instance ID with the proper name as it is SAVEC RRCF KaoPing. After that, we declare the workflow for SAVEC into views, and to do so we go to region config files, and therefore proceed to the workflow descriptor default, and then we copy one of the previous workflow descriptors, and we just change the name ID for SAVEC RRCF KaoPing. And after that, in order to display the workflow we just created, and the maps for the water levels, we go to the display data, and to do so we go to the region config files and to filters 5.0 in order to filter the subject data into views. And for that we create another filter ID for the water level in KaoPing, and we also create the description for this filter. We use the data we got from the import and export files of SOVIC in KaoPing area, and we have here the data. We just put all this data in those files here. As we see, we have like H simulated and Q simulated, same as with the import and export files we first import into views. And once we have the whole filters of SOVIC and the water level in KaoPing into views, we proceed to set up the SOVIC configuration, and to do so we first copy and import these the files from SOVIC, the SDKV, into the views module SOVIC file. After that we go to the SOVIC files, and then we replace the 07 KaoPing file with the one provided, and afterwards we go into the fixed file, and we look for the 07 under dash C 1730 BUI file, and we replace it with the one provided, which shows the event for the date we are going to display in the views. And at the same time we go back to the file we just replaced, the 07 KaoPing. We enter in the file, and we also do a modification on the file with the name WLM that previously had under dash, and we change it for an and. And after we configure SOVIC, we open the SOVIC software, and we start programming the settings in order to be able to run SOVIC later into views. So what we first do is to import the netcode, double click, and then OK. Afterwards we go to the meteorological data section, we double click it, and what we first need to do is to click in the edit select in the precipitation and select the previous file we just input into the fixed file, the one provided, which is the file of the event that will be displayed into views, which is 07 under dash C 1730 BUI. After that, once we select it, we set OK, and then for wind and temperature and radiation, we open this both. And we just click OK, and afterwards just OK, and proceed to the schematization. And for that, we double click and then click on edit model. So it will be display the map of the KaoPing area, and if it shows the map, it means that it's correct. So what we do is only save and close and then OK to proceed with the simulation, which we double click, and if we have this window emerging with the time step simulation running, it means that it's correct, and then we just need to confirm, then cancel, OK, and save the whole simulation case so we can later run into views. So To display SOBIC into Fuse, what we need to do is load the SOBIC RCF coping we created into Fuse and set the date. And what it's different to the other files we have loaded into Fuse is that this time we state selection for a call state, and after that we just approve and run the software. And if we get the simulation running as we did in SOBIC, it means that the SOBIC configuration into Fuse is working, so therefore a success. After that, the icons for the water stations will be displayed into the KaoPing catchment area. And what we need to do is just to click any or select any of the stations, and it will provide us the data with the water level during the event we program and selected from the configuration of SOBICs into Fuse. And just as a conclusion, the integration of SOBIC and Fuse offers a comprehensive solution for managing and forecasting weather-related systems. SOBIC is a hydrodynamic modeling software that simulates and analyzes the behavior of water systems, while Fuse is a decision support system for real-time monitoring and forecasting on hydrological conditions. The integration of SOBIC within Fuse, what we just did in the course, specifically in this exercise, enables the incorporation of advanced modeling capabilities into the decision-making process by utilizing SOBIC simulation capabilities. Users can obtain detailed insights into hydraulic behavior, such as flow patterns, water levels, and flood extents. These simulation results can then be fed into Fuse for real-time monitoring, forecasting, and early warning system generations. And the use of SOBIC within Fuse facilitates data exchange and synchronization, allowing for seamless integration between the two systems. SOBIC can provide a critical input data such as rainfall, water levels, and river discharges to Fuse for real-time monitoring and forecasting. Conversely, Fuse can provide boundary conditions and output data to SOBIC to enhance the accuracy and reliability of the hydrodynamic simulations. And both the combined use of SOBIC and Fuse enables improved situational awareness, allowing decision makers to understand the current state of water systems and anticipate further or future scenarios. The integration of real-time monitoring, forecasting, and modeling capabilities enhances the system's ability to issue timely warnings, optimize water management strategies, and support decision-making during flood events or water-related emergencies. However, the successful implementation of both SOBICs within Fuse, or Fuse in general, requires adequate data availability, calibration, and validation of models, as well as technical expertise in both of the systems we just saw. Thank you.